Okay, so in this video we'll be looking at oblique collisions. Now, oblique collisions are collisions that happen at an angle, or where the two particles are moving at an angle. So two smooth spheres, both of mass 2 kilograms, collide obliquely. Their velocities before the impact is 4I plus 3J. So if this is the first one, 4I plus 3J looks something like that, and I plus 2J. So I plus 2J. So it's moving that general direction. Okay, we know they collide along their I-axis. So because the impact is along the I-axis, the J component of their velocities remains unchanged. And I suppose similarly to that, if they collided along their J-axis, the I components of their velocities would remain unchanged. So let's lay out what we know as facts then. We know that their velocities before is 4I plus 3J and I plus 2J. We know they collide along the I-axis, so that means their J components remain the same. So the only things that are going to change are their I components. They're the only things that change. We know that the coefficient of, what does it say? The coefficient of restitution between the spheres is a third. Well, we know we have a formula for that already. We know that it's new velocity over old velocity is equal to minus E. Now with oblique collisions, we change that slightly. So dealing here, it's going to be V1 minus V2 over U1 minus U2 is equal to minus E, where V1 and V2 are coming from here, the new velocities that are changed, and U1 and U2 are coming from the initial velocities before they change. So right here you'll notice then, after filling that in here, where A and B is coming from the 4 and 1, we have one equation with two unknowns. So the second thing that we do is we use our conservation of momentum. We know that momentum before, now this is momentum 4 times 2 and 4 times 1. The momentum must be conserved, which is going to be 2 times P and 2 times Q. Now, it obviously depends then if these were different masses. If it was 5 and 2, you would fill in 5 here and 2 here and 5 here and 2 here. But it's just handy that they're 2 and 2. And we have then two equations with two unknowns. Very easy to find P here. You'd add the two of them together to find P. And then that leads us on to finding Q. So once you know P and Q, you've done the question, the first part of it, the new velocities. You'd fill that in here. We know P and Q. We want to find the loss of kinetic energy. So where is the kinetic energy lost? Well, it's lost to heat energy and sound energy on collision. Okay, so the loss in kinetic energy, really important then. So this is just filling in the velocities, as I said, filling in P and Q. The loss in kinetic energy, well, we know kinetic energy is a half mv squared. So this is the kinetic energy before the collision. Having found V, remember V must be speed. So we're changing the velocity to speed. Changing the velocity to speed. So we've found the V's before. And then we're finding the V's after. So again, the velocities, or the speeds after. We're changing the velocities to speeds. So they're all meters per second, changing the velocities to speeds. And then we're using the speeds to calculate the loss in kinetic energy. So it's the kinetic energy initially minus the kinetic energy to begin with, and then the modulus of that. Or you could take the kinetic energy at the end minus the kinetic energy at the beginning, and that would end up being a negative number, and you'd take the modulus of that also. So I'm just saying that you could do 26 minus 30 and you'd get minus 4, but you'd just take the modulus of that. Okay, next question. A very, very similar question. Two smooth spheres of mass 2 kilograms and 3 kilograms. Okay, so we know their masses are different. Have speeds 5 meters per second and 4√2 meters per second respectively. They move towards each other as shown, making an angle of tan inverse 3/4 and 45 degrees. Well, that tan inverse 3/4, the important thing to do, 3/4, would be to change that tan theta is equal to 3/4, and then we know the Pythagorean triple that would come out of this, 3, 4, theta, this is going to be 5, so we can find what sine theta and cos theta are straight away. Find what sine theta are and cos theta are straight away. We know the coefficient of restitution is 7/8. Okay, so again here, we're finding what sine theta are and cos theta are straight away. We're changing their speeds. Remember, the speed, which was 5 meters per second along here, we're breaking that down so we have it in I and j. So I and j. And similarly, you could probably tell that this is going to be moving negatively on the I direction. It's moving backwards. So we need to do the other one as well. It's going to be moving backwards, so negative in the I direction, but positive in the j direction. So it's a negative 4√2, 1/√2i. And then multiplying 4√2 by 1/√2, because that's what sine of 45 degrees is. We're getting it's moving in the negative direction, the I, but still moving positively. Okay, it's clear to see from the diagram what they collide along. They collide along their I axis. Here, they collide along the I axis, so that means the j velocity is going to remain the same. So laying it out in our table, we know velocity to begin with. The j velocity is going to remain the same. So p and q are our only unknowns here. We know that it's nu over old is equal to minus e. And you can do p minus q is equal to 4 minus minus 4. Yeah, 4 minus minus 4 is equal to minus 7/8. And what you're going to get on the right hand side here is one equation with one unknown. Similar to the previous question, you're then going to do conservation of momentum. The mass times u. The mass times u. You're doing the mass times p, the new velocity, and the mass times q. Yeah. And a second equation with two unknowns. The question asks us to find the velocities before the impact. That's the very first thing we did. That's done. The velocities after the impact, we'll find that by finding p and q. And the loss in the kinetic energy is similar, exactly the same as the previous question. So find p and q by using simultaneous equations. That's not difficult. We then need to fill p and q into here, just so we answered the question specifically. So it's going to be minus 5i plus 3j. And think about that. If this ends up being, so it was 4i plus 3j before the impact, and then it ends up being minus 5i plus 3j. It looks like it's moving like this to begin with, and then it bounces backwards. How do I know it's bouncing backwards? Is because of the I. And this one, the other one, is minus 4i plus 4j, ends up being 2i plus 4j. So it was moving to the left and up, and then it starts moving right and up. So they bounce off each other. They want to find the loss in the kinetic energy. To find the loss in the kinetic energy, important to find the velocity. So I've changed 4i plus 3j. And I'm going to change that, that's its velocity, I'm going to change that to speed. So find the modulus of it, 4 squared plus 3 squared. But then I'm going to square it again. Look, it's squaring it again. So it's effectively just writing in 4 squared plus 3 squared because the square root cancels each other out. So I can take a little bit of a shortcut there. So I'm filling in 4 squared plus 3 squared. I'm filling in minus 4 squared, 4 squared. And look at that. the reason I'm not filling in the minus here. I really should technically fill in the minus, but because it's going to be squared, I don't really mind. Similarly over here, there should be a minus there, but it doesn't really mind because it's going to be squared out. Squared, 3 squared, 2 squared, 2 squared, 4 squared, 4 squared. Exact same question. We're finding that it loses 9 joules. If you did it in reverse order, as in did half mv squared, v1 squared plus a half mv2 squared minus all of this, you just get minus 9 joules. So you'd say the change in joules would be minus 9, and it would be plus 9, the change in joules. Okay, and the last question for the video. 2 smooth spheres of mass 4 kilograms and 2 kilograms impinge obliquely. So they hit each other obliquely. The 2 kilogram mass is brought to rest by the impact. The coefficient of restitution is a half. Prove that before the impact, the spheres were moving in directions perpendicular to one another. So I want to show they're moving perpendicularly to each other. Doesn't really tell me an awful lot about the question. I know that the 4 kilogram mass and the 2 kilogram mass, fantastic. I don't know their velocity before. I don't know the velocity after. I don't know the velocity after, but I do know it says the 2 kilogram mass is brought to rest by the impact. That's important. The 2 kilogram is brought to rest. Really, really useful. Okay, well, we don't really know what else to do. We know the coefficient of restitution. Oh, brilliant. We know the coefficient of restitution, but I don't know what else to do. So let's just do what we've done all along. Use that new over old is equal to minus e and use the conservation of momentum. So here, I'm using new over old, new over old, new color, over old is equal to minus e, and I know what that e is, it's a half. Now I'm working down to an equation with 3 variables. Okay, fine, 3 variables. Let's not panic about that. And I'm using the conservation of momentum. Okay, so I'm just going to delete a bit of the highlighted so I can talk a little bit freer. Okay, conservation of momentum. Well, writing out my formula that I'm going to use, I know my masses are 4 and 2. So they're not the difficult bits, 4 and 2. The velocity to begin with, and the velocity to begin with, the velocity to finish with, and the other one is 0 for the V2. So again, a second equation that I'm working down to with 2 unknowns. And now remember, keep an eye on the prize. What did I want to show? I want to prove that before the impact, the spheres were moving in directions that were perpendicular to one another. Before the impact, that they're moving perpendicularly to each other. So this should have been an A there. Okay, so we've got 2 equations then with 3 unknowns, but there might be something quite nice about all of these unknowns. If we multiply equation 1 by 2, look what happens when we multiply equation 1 by 2. We get minus 4p plus 2a minus 2c. And with equation 2, sorry, just need to delete that. With equation 2, if we do actually no manipulation at all and leave it the same, we'll find that the c's and p's cancel. And that leads us to having a equals to 0. Okay, so I know this is equals to 0 here. This is 0. Okay. So think, not the I and the j component is going to change. So we've found that the I component has changed. So if the I velocity has changed, it's gone from 0 to p. That must be... So if the I components have changed, okay, so this I component and this I component has changed, that must mean the j components have stayed the same. So if the j components have stayed the same, that's why this is b and b, that means this must be 0. D must be 0. So we know then that if d is equal to 0, as the j components are unchanged, the velocities before the impact are 0 and b, and 0I plus bj, ci plus 0j, and that these are perpendicular, and that's the question proved then. Ooh. That's the question proved, that they are moving perpendicularly to each other.